All right, so I got cut off from the last video, so that just means I need to hurry up and wrap it up. So if we look, this is another way of viewing the tricellular model of the atmospheric circulation. So we see just a different view of the same thing. So again, right across here, we're looking at that 0 degrees latitude, so that's the equator. Here's about 30 degrees, this is 60 degrees, and then the North Pole. So you see those three cells, okay, in each hemisphere. And remember, they're always going up in the same area. So if air is moving up in this cell, it's pulling air up in the other cell as well. And we see that at those low pressure areas, we get a lot of precipitation. At the higher pressure areas, we tend to have drier conditions. So that means not as many clouds, not as much precipitation. Okay. So we're thinking about patterns in precipitation. We're thinking about the currents and how they're carrying heat from the equatorial regions toward the poles as well. So how that carries um, a lot of energy from the equator toward the more northern latitudes or the more southern latitudes, depending on the hemisphere that we're focused on. So pause again. So this isn't a demo, but it's just something to think about. So it says, on a very hot and sunny day at the beach, would you prefer to walk barefoot in the dry or wet sand, and then why? So just pause, think about it, and then come back. All right, so I hope you thought about it, and I feel like any reasonable person would say on a very hot and sunny day, you would want to walk in the wet sand if you didn't have any shoes, because the dry sand gets super, super, super hot and can almost feel like it's burning the bottom of your feet. So what does this have to do with anything? So when we're looking at the locations of the biomes and these climatological patterns, we have to think about water because the presence of water moderates temperatures. So that means that there's not as extreme of temperature fluctuations in zones that have abundant water. So I like to think about, I can't remember, maybe 2 summers ago, my husband and I decided that we would drive from California back to Colorado, but we would take the southernmost route um, across across the United States to do that. So we ended up driving through Arizona, so the desert of the United States, so the southwestern desert of the United States in the middle of summer. So I think it was sometime in July. And it, I think it was something like 48 degrees Celsius in zones that we drove through. So it was getting really close to 50 degrees Celsius. And it was unbelievably hot. I mean, we were in the car most of the time, so we had air conditioning. But these dry zones, so these dry zones are able to heat up a lot, but they still have really big temperature fluctuations. So even at night, it would have cooled down significantly in that area. But we just happened to be driving through in the middle of the day in July. And, I think that was just poor planning on my part. I just really wanted to drive there because I'd never seen that area before, but it was unbelievably hot. And I feel like when I got out of the car, it was like stepping into an oven. It was really not for me. Um, but anyway, so if we're thinking about these dry versus the wet zones, so wet zones are more moderated by the presence of water. And that's because water has the ability to absorb a lot of energy. Okay? And if we remind ourselves of these transformations, so when water goes from solid to liquid to gas, it has to absorb a lot of heat in order to go through that change in state or that transformation. So the amount of energy that is required to change the state of water is called latent heat. So it's just looking at this quantity of heat that is required. Typically, we're thinking about that is required to take liquid water and to make it gas, we have to make it water vapor. Okay. So thinking about water as well, we're adding in some information about productivity. So when we think about productivity, we're usually looking at the net or gross primary productivity, so for those producers, and thinking about how much energy they're capturing, or if we're thinking about the gross is kind of how much energy they have available after they meet their own needs. So how much extra they're produced within a certain time period. Now, if we're looking at productivity, we would imagine that if we have a lot of solar energy and a lot of precipitation, we'll have more productivity, which is, what you'll see as you're doing the POGL. So if we go through and we think about the presence of water in these different areas, well, some of the areas actually have very similar temperatures. So we could have, a temperate deciduous forest and a temperate grassland, or what would be referred to as a temperate rainforest. So this is a less common type of ecosystem, but they do exist. So the difference really is the amount of precipitation. So this P is just precipitation. So the difference between the temperate deciduous forest and the temperate grassland, as we'd see in our activities, is that the grassland gets far less precipitation than the deciduous forest. So a grassland does not get enough precipitation to support these large trees that exist in the deciduous forest. If you look at the second bullet, it's talking about the rate of precipitation and evaporation. This is kind of telling us, well, how much rain do we get versus how much evaporates. So if we get a lot of rain and it evaporates immediately, then there's not going to be a lot of available water. So we're thinking about that ratio, if we get a lot of precipitation, so if we have this high ratio, we get a lot of precipitation, very little evaporates, so that means there's going to be a lot of water available on the ground, available to plants, and available for their growth. So thinking about these biomes, I want you to be aware that the biomes can shift. So even though we had the map and we saw where they're currently located, there's a lot of predictions about the shifts in these different ecosystems with changes on Earth, like global climate change. So the temperature on Earth is expected to increase 1.5 to 4.5 degrees Celsius by 2100. So that's not that far away. If that's the case, then we're expecting a few things. So we're expecting warmer temperatures, particularly at higher latitudes, so that means closer to the poles, warmer temperatures, as well as warmer temperatures in the winter. Okay, so thinking about that change in that the winter season as well, within the northern region and the southern region of those hemispheres. Of the, respectively, the northern region of the northern hemisphere and the southern region of the southern hemisphere. If we have this increase in temperature overall, we also fear stronger storms, and we'll talk about that likely again later on. But this more energy that there is to evaporate water, the more moisture we have in the atmosphere, the more energy we have just within the atmosphere, so moving the air around, the stronger and more severe we expect storms to be. And in fact, it seems that if you study the past 5-10 years, there have been way more frequent severe storms than there had been in the past. So it's just interesting to keep an eye on that. So if these environments are changing, I want you to be aware that if the environment's changing, then the ecosystems will change as well. So if the weather and the climate changes, the ecosystem will change, and actually they will relocate. So this means that animals and plants will be able to migrate to zones that will more appropriately meet their needs. Okay, so they will likely be moving to slightly different locations. The final thing, I think this is the final thing, I think that I left on this one because I tried to cut this a little bit shorter. The biome shift also has some benefits. So it's not just negative, okay? So this means that if there are warmer temperatures, not only does it mean that, okay, maybe we would go outside more in the winter in areas that would typically be extremely cold, but there's less sea ice to interfere with human activities. Okay, we also know if you've watched any videos that there's also less sea ice for the polar bears to be fishing. But if you think about benefits for humans, there are benefits for humans as well. So something just to think about, that everything has its pros and cons. Okay, so make sure you complete all of your homework and let me know if you have questions at the beginning of next class. Okay, have a good evening.